Hi, and welcome to this tutorial. This one's about electrical forces between two objects and how it increases with charge and decreases with further spread apart distance. Here we go. Which of the following statements is true about the magnitude? Magnitude is size, people, size of a force between two objects, each holding an electrical charge of positive 3 times 10 to the negative third coulombs. The hotter the objects are, the greater the electrical force between them. That is false. Okay? The closer the objects are, the greater the electrical force. That is a true statement. Let's just double check though. The faster the objects move, the greater the electrical force between them. That's false. The colder, nope, that's about temperature. Here we go. So, magnitude of force, closer they are, greater the electrical force between them. Here we go. Which of the following would cause a decrease in the magnitude of electrical force between two objects? So we're looking at what's going to cause a decrease, what's going to make it smaller, the main size. Temperature, again, we're not looking at temperature for these, okay? If we decrease the distance, this would cause an increase. Okay, this one here, increase the distance, that's going to cause a decrease. So if I increase the distance between the objects, it's going to cause a decrease in the magnitude of electrical force. Which of the following would cause an increase in the electrical force between two objects? So again, we should circle the word increase so we remember that's what we're talking about. If I increase the distance, remember we said if we increase the distance, we're going to what? Decrease the electrical force. So that's not it. We don't want to make the charge opposite. We're not going to make one hotter. We're going to, increase the charge on one of the objects. If we increase the charge on one of the objects, we will increase the electrical. Which of the following pairs of variables affect the magnitude of electrical force between two electrically charged objects? The kind of the charge on the object and the distance between. Okay, what's wrong with this one? You might be thinking, well, that's about the charge, so it's right, but it uses the word kind, and remember we said it was the magnitude, the size. The temperature, nope. The material that a charged object is made of, nope. The magnitude, so the size of the charge and the distance between. Those are going to have the variables that affect the magnitude of electrical forces. An electrically charged object is surrounded by an electrical field. An object with a like charge is brought into the electrical field and the two objects repel. What is repel? They don't like each other. They try to get away. Use the following two diagrams to answer the question. Which of the following statements is true about the magnitude, remember magnitude is size, of the electrical force between two electrically charged objects in Model A compared to those in B? Well, let's look. Let's compare. Model B, the D is 1. Over here it's 2, so it's further spread apart. So right away we know, because the charges are the magnitude of the charges are the same in both objects to each other, that the Model A is going to have a stronger electrical force. Why do we know that? Because the distance between the two charges is less. So when we read the magnitude and the force of force is greater, nope, it's not greater in Model B. So anyone where it says the magnitude of force is greater is wrong. So that gets rid of B, A, and C. So now we're down between B and D. B says the magnitude of force is greater in Model A because the magnitude of charge is greater. No, they're not greater. It's the same. So that leaves D, which says the magnitude of the force is greater in Model A because the distance between the charge is less, and that's the correct answer. Which of the following statement correctly compares the magnitude of the electrical force between the electrically charged objects in Diagram 1 and Diagram 2? Well, let's look. Diagram 2 is 2 meters apart. Diagram 1 is 1 meter apart. Okay, so right away we know that Diagram 1 is going to have the greater electrical force. The magnitude of force between the objects in Diagram 1 is greater than the magnitude of force between the objects in Diagram 2. Dang, that's the right answer. Why is it they're greater? Because the size. The diagram below shows two electrically charged objects separated by the distance indicated. Use the two diagrams to answer the question below. Apologize that it's covered up, but that's what happens sometimes. Sometimes we try. So 2 meters, 1 meter, 2E, 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 2E. Oh, look, this one's going to be greater force. Okay? And so with this greater force, we know that the magnitude of the force is going to be greater in diagram 1. So let's read. The magnitude of force between the objects in diagram 1 is greater than the magnitude of force between the objects. There we go. That's the correct answer. There we go. Because, what did we say? The magnitude of force is greater in between those two objects. The magnitude of electric force between two electrically charged objects will A, increases the level of charge of the object increases and increases distance. Wait a minute, they said it's going to increase as distance between them increases. That's false. Increases the level of charge of the object increases and decrease as distance between them. That sounds close, so let's keep looking. Decreases the level of charge. Nope, because as charge increases, they're going to increase. They're going to increases the level of charge of the object increases, but say nope, because they're not going to stay the same as the distance increases. Okay, correct answer. So the magnitude of electrical force between two electrically charged objects will increase as the level of charge on the objects increases and decrease as the distance between them increases. The 4 following diagrams below each show two electrically charged objects separated by the distance indicated. In the diagram, C stands for coulomb, which is a unit of electrical charge. Use the 4 diagrams to answer the following questions. In which model is the magnitude of force of attraction between the two objects strongest? Okay, we're looking for strongest. So right away, let's eliminate 2 answers. Why am I going to eliminate 3 and 4? Because the distance is more in 3 and 4 than it is in 1 and 2. Right away, we know that's wrong. So C and D are out. In diagram 1, the charge is 4C. In diagram 2, it's 2C. So that means the magnitude is bigger in 1, so that's going to have the strongest attraction. Okay? The 4 diagrams below each show the electrically charged objects separated by the distance indicated. Use the 4 diagrams to answer the following question. And in the diagram, C stands for coulomb, which is a unit of electrical charge. Identify the 2 diagrams in which the magnitude of electrical force between the objects is equal. Ooh, we want it equal. Okay? When we look at number 1, diagram 1 and 2, we notice that, nope, they're not going to be equal because in the second charge, or the second object, the magnitude of charge is much bigger than it is in the diagrams 1. So A is out. Diagram 1 and 3. Okay, if you notice, in diagram 3, it's exactly double what 1 is. But keep going, because notice our distance is double. So because distance is double and charge is also doubled, we've negated the fact that our attraction would have decreased over distance because we increased the charge. So this is a possible answer. They sure are similar. In C, diagram 2 and diagram 3. Nope, because number 1, the distance is doubled and they're not there. Diagram 3 and 4. Again, distance is the same, so we're okay there, but the charges aren't matching up. The reason, again, that diagram 1 and diagram 3 are equal because even though it's 2D, the magnitude of the charge is doubled to counteract the fact that there's more spread apart. Okay, guys, I hope you better understand about electrical force and how it's impacted by the size of the charge and the distance apart the charges are. Thanks, guys. Have a good one.